This is our video solutions for Can You Do 46. Can You Do 46, 47, and 48 include quite a bit of review of the entire unit. So what I'm going to try to do on those Can You Do's is include the page number from our notes that you can go to refresh your memory on how to do some of these problems, because for some of you it may have been a couple of weeks since you've looked at this, since we're just coming out of Christmas break. So I think that Can You Do 46, 47, and 48 are really good leading up to our test. Our test is going to be on January 18th and January 19th, depending on whether you're an A day or a B day. The one other thing that I want to mention about this being a review is keep in mind that the unit that we're on includes more than just the packet that I've given you. So in class, I gave you the rest of our notes for this unit starting at page 413. And as some of my students have gone through and started these Can You Do's, they've forgotten that we have notes that go back to 400. So just remember that all of the information isn't in this one packet. You have from page 400 to page 424, I think we end up ending on. So remember that we've been talking about scatter plots and the relationship between two quantitative variables for quite some time, so you may need to go further back in your notes to get the help that you need to make it through these problems. Okay, that all being said, let's just get going. I often try to write down what problem we're doing so that you guys can skip ahead, and then I just forget. So I'll try again, and hopefully this helps you drag at the bottom and just go to the problems that you need, but I apologize in advance if I forget. So we're looking at number one. Number one is just straight up pretty much the definition of the least squares regression line. If you watched your notes, this problem is hopefully pretty easy for you. It's page 419, and I had you guys write in that this minimizes the sum of the squared residuals. So that is option D, as in dog. Number two requires you to use page 420. Most of all of you that I have seen working in class are doing just fine with this. So A, when you write your regression line, it's okay if you round it differently than me. The one thing that I want to make sure that you add in is defining your variables. So where X is pre-exam total and Y is, hopefully you're noticing that I need to have the word predicted final exam score. See, I already forgot to put up number two. I mean, guys, I am not good at this, but I'll try to get better. I will try to get better. So if you just scan, try and find number two. I already talked about this for like a minute. When you're deciding what is Y and what is X, you want to pay careful attention to how they tell you what the variables are. So in this case, the way they worded it is what would lead you to be able to figure out what was Y and what was X. B, use the line to predict Julie's final exam score. I got 78.2. Depending on how you rounded your line, yours might be a little bit different than mine, but probably very, very close. There's no real units here. I guess you could say points. And there's no interpretation. So if they asked you to predict a value, you show your work. Make sure that you always show your work. And then on your answer include units, but then there's no interpretation after that. I am looking around for a highlighter because I want to make sure that you are showing your work. Some of you guys have a lot of opinions about this, and I understand them, but I would hate for you to miss points because you don't want to show the work. Okay. Moving on to number 3. So once again, just page 420. My work is shown here. I guess I could have done a little bit better to say that this is B. I believe slope is the letter B. Now that I'm wondering, oh yeah, I labeled it up here. So B is our slope. Answer is A as in alpha. All right, number 4. Similar to the last problems, you're using 420 as your guide. It asks you to find slope and y-intercept. So those answers are echo. And number 5 is alpha. Number 6, now this guy, he's kind of a doozy. I was unsure on letter A. I was unsure if letter A was true. So I just skipped letter A and then went back through, or not, sorry, I didn't go back through. I skipped letter A and started at B. So a plot of residuals is useful for assessing the fit of the least squares regression line. On page 415 in our notes, it tells us that it's actually the most important thing to look at when you're assessing fit. So when deciding if a linear model is appropriate, a residual plot is the most important factor. So B is definitely true. The value of a residual is the observed value minus the predicted value when using the least squares regression line. On page 413, observed or actual value minus predicted value. So B and C are true. An influential point on a scatter plot is not necessarily the point with the largest residual. So you guys have had some trouble with influential points, and I hope that I've made it clear by now that if you're struggling with influential points, what you want to focus on are problems like this. So if you're like, I don't know what happens if we add or subtract or to put the point on or take the point off, like, I don't know about that. Try to do problems like this. Just focus on those questions in the reviews, and if you feel good about those, then you can forget about the stuff that's troubling you. So on our influential notes or influential points page, page 418, we have, and I'm sorry I can't really get this straight because of my, I'll just take it out. Sorry, I'm rushing because I hate to waste your guys' time, but being clearer is probably better than rushing. So you can see here that this is an influential point and this is an influential point, and they don't have high residuals. So yes, influential points can have a very large residual, but they don't always have to have one. You can have an influential point that has a residual of 0 and still be very influential. So I know that D is true. Now let's say that we're unsure about A and D, but we know for sure that B and C are true. We could at least deduce then that it's echo. We can know nothing about influential points and be unsure about this one and still get this question right. Now, in our notes for least squares line, it does say that when you add the residuals, the sum equals 0, but I did not go out of my way to say that it always equals 0. Number 7, the fraction of variation in the values of a response y that is explained by the regression of y on x. So this is a very complicated way of describing r squared. So we're on 7 now. We're looking at a very complicated way of describing r squared, and you will see this again. It's likely that you will see this on your exam. So whenever you see the word explained in regard to regression, if they are including the word explained, it's almost always a problem about r squared. It is almost always a problem about r squared. If they say the word explained, they are probably asking about r squared. Well, the correlation coefficient is r. The slope of the least squared regression line is b. Square of the correlation coefficient is r squared. This is a. Sum of the squared residuals, that doesn't have a letter. So it has to be C as in Charlie. This is the definition. If we go back to page 417, we can see that r squared is defined as the amount of variation that is explained by x. It's that word explained that should lead you to conclude it's r squared. Okay, cruising. 8. Hang on, I'm going to pause for a second and just check my sound. Okay, I'm back. It was fine. Number 8, he's kind of tricky. So we have our least squared regression line here. It says by looking at this line, you can see that the correlation between height and arm span is. Well, it can't be C or D because this is slope and this is y-intercept. But can it tell me if it's positive or negative? So greater than 0 is just their complicated way of saying it's positive. And less than 0 is their way of saying it's negative. Can this line tell me whether or not the correlation or the relationship is positive or negative? So when we see correlation, this is R, which is the relationship between the variables. Well, on page 421, in our notes for computer output, which you guys, some of you guys haven't done yet, so I apologize if you haven't done the computer output lesson yet. In that lesson, we learned that correlation has the same sign as the slope of your line. So if the slope of your line is positive, then your relationship is positive. So we can conclude alpha. We can say our relationship is positive. In addition to the regression line, the report says that r squared is 0.95. This suggests that. So the first thing that we want to look for is the word explained. So I'm going to quickly go through and see if I see that word. I don't. So then the other word I'm going to look for is accounted. Explained or accounted. And now this gives me C, D, and E as options. So then the last thing, or even maybe the first thing you could have looked for is the word variation. Variation, the only one that includes that description is D. So 95% of the variation in height is accounted for by the regression line. Or 95% of the variation in Y is accounted for by the line. Okay, 10 goes all the way back to page 413. You're finding a residual, which means that first you must find the predicted value. So we know X, we know Y. To find the residual, we need to know Y hat. We get a residual of negative 3.2. If you had me on a B day, I think that we got this answer wrong because for some reason, I didn't do it when I talked about the answers with you. I did all the other ones but this one. So this one is alpha. If you've forgotten how to find a residual, please go back to page 413. Number 11, suppose that we add in a very tall child with an arm span of 120 and a height of 118, what will happen to, it looks like they want us to look at correlation and slope. So the first thing is, they're telling us that this is a tall child, which means you're going to have a large X value. This is a tall child, so you're going to have a large X value. So when they talk about correlation, what happens when we add a child with a large X value? Well, in this case, it increased correlation, and in this case, it decreased. So we know that it will have some effect, so it can't be D or E. And then our only option is correlation will increase, so we don't even have to worry about whether or not it's an increase or a decrease. But then the next one wants to know about slope, which means we should probably figure out how far away from the line this point is. To figure out what happens to slope, based on what I know from influential points, I need to figure out how far away this new point is from my regression line, which means I should find the residual. Well, if I go through and use my equation and calculate the predicted value, it's the exact same as the actual value. So my residual is 0, which means that this point is right on the line. And if this point is on the line, your slope will stay the same. So a residual of 0 means on the line. If it's on the line, your slope stays the same. Correlation will increase because it's basically this example. You add a very tall child that is on the line. What happens to slope and correlation? Correlation increases by quite a bit. Slope stays the same. Then last one, suppose that the measurements of arm span and height are converted from centimeters to meters by dividing each measurement by 100. So, family, the last number I wrote down was 8. I'm so sorry. We're all the way on the last question. Sorry, family. I apologize. Okay, so this question I believe is the most challenging one because you have to use your knowledge from last unit and combine it with your knowledge of this unit. So first things first is R. Well, remember that R squared is equal to R times R. And we have a whole page worth of things about R that we need to know are true. So on page 407, we talk about how it doesn't matter if you change the units, you flip the axes, you convert your measurement, R will stay the same. So that's this one. R has no unit of measurement, so R does not change if the unit of measurement changes. So I know that R is going to stay the same, which leads me to choose between D and E. Well, what will happen to S? Remember that S has to do with distance. It has to do with spread. Like, it's the spread of your residuals. Like, the best way that I can say it is that it's like the spread of your residuals. Now, S is related to spread, or you could think about it as standard deviation. Well, back in our transforming data lesson, if we divided by a number, we divided our whole data set by a number, our spread shrinks. So here we multiplied, this is the original, we multiplied and it spread out. When you divide, it shrinks in. So our S is going to decrease because we divided, and the reason that it decreases is because it's related to the spread of the residuals. Okay, that's it. I apologize for my horrible numbering. I try to make your guys' lives easy, but sometimes it just falls short. As usual, if you have any questions, please let me know. One note on that, Famil. When you guys email me and tell me, I don't understand anything about residuals. I don't know how, I need more information to help you. I know how to help you, but I don't even know where to start if all you tell me is I don't understand any of it. You have to determine one of the most important things that you can do as a learner is figure out, where do I get lost? Where do things start to become unclear? And then tell me, I was good until this point, and then I don't know what you're talking about. So please, if you need help, I want to help you. I mean that so genuinely. I would love for you to ask me questions. But ask me questions. Don't just tell me I don't understand any of this, because I don't know where to start when you tell me that. Okay, that's it. Love you guys. Hope you have a great day. I appreciate you watching this video, especially if you made it all this way. So, proud of you.